All right, here we go. Question number 6 of our college algebra homework number 6 in MyLab Math says to determine whether the function is 1-to-1. We can do that with the horizontal line test. If it is, we're going to find a formula for its inverse. All right, so the first thing that I want to do is I'm going to go to Desmos and I'm going to graph that function real quick. X to the third minus 2. And I'm going to check and see if that passes the horizontal line test, which it looks like it does. Every horizontal line, even right in here, is only going to touch one time. So this passes the horizontal line test, okay? But if you don't have access to Desmos, you're going to have to know how to check that algebraically. So here's how you can check for 1-to-1 algebraically. You're going to check and see, is f of negative x equal to f of x? If that is true, then this is not 1-to-1. All right, so we're going to replace every x in the function with negative x first. That's going to be negative x cubed, and it is important that you put those parentheses. And we want to check and see, does that equal the original function, which is just x cubed minus 2, okay? So a negative anything, negative x to the third, that means negative x times negative x times negative x, which is going to end up being negative x cubed minus 2 equals x cubed minus 2, and those are clearly not the same. Negative x to the third minus 2 is not the same as positive x to the third minus 2. And since those are not equal, then that means it is 1-to-1, okay? So this is 1-to-1. And now that we know that it's 1-to-1, we can find the inverse. And so taking the original function, f of x is x to the third minus 2, we're going to use the 3s method. From my previous 2 videos, I've talked about the 3s method. That is substitute, switch, and solve. So the first thing we want to do is we want to substitute for f of x. We want to replace it with y. And then we're going to switch x and y. And then we're going to solve for y. So to solve this for y, we're going to take the negative 2 and bring it over. That's going to give me x minus 2 equals y to the third. And then I've got to get rid of this exponent of 3 on the y to get the y by itself. How do you get rid of an exponent? Well, you have to use a radical with the same index. So I need to take the cube root of both sides. So a cube and a cube root cancel. That gets the y by itself, and now we can say this is the inverse. So this is the notation for inverse. The inverse function is the cube root of x minus 2. And then what I'm going to do is I'm going to use Desmos to prove it. All right, so we're going to put for g of x, we're going to say that's the inverse function. And then I've got to know, how do I do a cube root in Desmos, okay? Well, I've got a square root, but in order to do a cube root, I'm actually going to have to come over here to the functions, and I think miscellaneous, and you see here is a button for n root, any root. And then I can fill in third root of x minus 2. And I want you to notice that looks weird. What did I do wrong? Oh my gosh, do you see my mistake? Look at this. Up here, when I took the negative 2 and brought it over, what should have happened to that negative 2? It should have become positive. Positive, and then let's check and see what happens. You know what gave me a red flag is that these are not symmetric about the line y equals x. So let's change that to a plus 2. And now you can see the symmetry. So let's put the line y equals x, and let's check for symmetry. Bam, do you see the green line, the y equals x, should come up and split the blue and the red right down the middle. That looks pretty and symmetric. And I'm so glad I checked that. Whew, I caught my mistake with Desmos. So let's see if MyLab Math likes that, using this button for cube root of x plus 2. Bam. And so I hope that was helpful, and I hope you see that I'm a person too. I make mistakes, and these tools that I'm showing you can help you catch your mistakes when you make them. Okay, so I hope that was helpful. If you have any questions or comments, feel free to put them in the comment section below, or you can text me, and thanks for watching.